Good day, ladies and gentlemen. In today's lesson, I want to talk to you about what it means to be a function. You've heard us throw that word around quite a bit over the last few weeks, and now I want to give you the formal definition. So, the word function in the English language means something that is working or useful. And mathematically, we're going to consider a function a relationship or an equation that is working or useful. That's going to mean that in order for our relationship or equation or graph in that the picture representation to be useful, our x values are going to have to be unique. They may not repeat. Another way of saying they may not repeat is what I had just suggested. They must be unique. So you'll hear me say that a lot this year. In order to identify if a relationship is a function, I'll say, are the x values unique? And in order to determine that, you'll have to look and see if they repeat. If they repeat, they are not a function. They must be unique. Most often, the x values in real life represent or measure time. In real life scenarios, the x-axis is most often time in terms of seconds, minutes, hours, days, weeks, months, etc. The measured amounts over time are often used to make predictions about what is going to happen in that information in the future. So the y variable is the measured amount. It's our predicted measured amount of whatever it is we're investigating. And since a function must have a unique x value, what this suggests is this. We only want one prediction at a time. That's why we want our x values to be unique. It will allow us to have one prediction at a time. Multiple predictions at the same time would be useless and would be not considered a functional relationship. So before I move on, let me take a second and give you a little quick sketch of what that would suggest. If I simply create an x and y axis, typically what I would suggest, or as we've suggested throughout the year, is that 90% of the time the x-axis is time. Weeks, months, years, seconds, doesn't really matter. The y-axis is whatever it is we're measuring. Temperature, money, so degrees, money, weight, whatever it is we're measuring. And what we would suggest most often is that in terms of time, the center of the graph is typically right now. Anything beyond right now would be considered the future. And anything to prior to right now, where our x values are negative, would be considered the past. And what we most often do is we take data and we try and investigate information from the past to make predictions into the futures. Okay, so if I move the labels out of the way for just a moment, I can give you a little better idea of what we're talking about. We've looked at a lot of linear relations lately, and we've looked at patterns that are a result of repeated addition, and they're typically going up over time. And if I were to suggest that, say, we had 1 month ago, 2 months ago, 3 months ago, 4, 5, and 1, 2, 3, 4, 5 months from now, we could suggest that we have noticed that over time, some relationship, maybe it's somebody's health, maybe it's the amount of white blood cells that they're trying to produce, which protect them from many different attacks on the body. And we might have noticed that their white blood cell count was increasing over the past in a very repeated, predictable pattern. And based on where it is right now, if that pattern continues, we can make predictions into the future where it might be 1, 2, 3, 4, and 5 months from now. Where we run into a problem is if we ever see something like, say, this. In this particular relationship that I just graphed, which is clearly not linear because it doesn't make a straight line pattern, there's curves in it, this would be difficult to interpret. And it would be difficult to interpret and make a prediction from because if we went, say, 1 unit at a time from now, we might be able to identify the fact that at 1 unit at a time from now, the relationship, the orange relationship, appears to measure 0. But at the same time, it has a predicted value way up here and one as well down below. So let's give some dimensions to that, some measurements. Let's say 1, 2, 3, 4. So we'll say at time 1, it could also have a measured amount of 4. And we'll go 1, 2, 3. And we'll say that it could also have a measured amount of -3. So there are 3 possible predictions 1 unit of time from now. This could measure 0. This could measure 4, or it could measure -3. Now think about what that means in terms of real-life interpretations. If, say, you were going to take a pill to get better from something, so a doctor prescribes you some medication, and the increased value means you're getting better, the value at time 0 means you're staying the same based on taking that pill, and the negative value means you will die. You might not want to take that pill. You would want something that's more predicted. You would want something more like that linear pattern that's clearly increasing and you're going to feel better after you take it. That's why we consider certain relationships functions and others not functions. It's real simple. In order for a relationship to be a function, the x values must be unique. They may not repeat. If the x value repeats, if you're seeing 1 over and over again with several different predicted measure amounts associated with it, that means there's more than one prediction at a time, and that is not a function. And it's that simple. There's a lot of different ways we can look at that. And the first way is if we were dealing with a graph. If you're dealing with a graph, the easiest way to determine if it's a function is what we call the vertical line test. So the vertical line test, when analyzing a graph, determines the function, use the vertical line test, suggests that if you take a vertical line, which is a line that goes straight up and down, and you slice the graph with it at every single possible place, there should only be one point of intersection at all points in times. So based on that, what we would do is this. You can take your ruler to pretend that it's a vertical line, and that's kind of the easiest way to do this. And if you just place your ruler along any of these relationships and you slide it, you should make sure that at every point in time, there's only one point of intersection. So if you look over here, if we go back 5 units of time ago, and I'll clone this real quick so I can do a bunch of these for you so you can see it really well, as if I were to pause it at different points in time. So if I didn't slide it, but I had multiple rulers, I could set them up in various places along the graph, and I could see, is there only one point of intersection? Seeing if there's only one point of intersection indicates that 5 units of time ago, the relationship measured 0, right there where it crosses the vertical line. 1 unit of time ago, the relationship measures 3. 3 units of time from now, the relationship appears to measure 4. And if I go out to, this looks like 8 units of time from now, it appears to measure somewhere in the neighborhood of 7. So I've got 8 comma 7. I've got 3 comma 4. I've got negative 1 comma 3. And I've got negative 5 comma 1. At each point in time, each x value, negative 5, 1 unit, 5 units time ago, 1 unit time ago, 3 units time from now, 8 units time from now, there's only one prediction. Now that's different than graph number 2, because in graph number 2, if I were to do the same thing, and I were to take a vertical line and try and bring it along the graph, in the first portion of the past on the left-hand side, there is only one prediction at a time as you watch where the relationship crosses my vertical line. But once I get to the positive values, you can see that from like 1 unit time up to 4 units of time, there's this overlapping data. And in that overlapping data section, what's going to happen is there's going to be multiple predictions, as I just shown you a moment ago. 2 units of time from now, it appears that it can measure negative 1. It also appears that 2 units of time from now could be about 3. And it seems that 2 units of time from now, it could also be roughly 4. So there's 3 predictions at that point in time, and that would make this not a function. The previous relationship was a function. That's a linear relationship. We know that's a linear function. If you do the same thing for number 3, ladies and gentlemen, I'm hoping that it's pretty obvious that in this particular relationship, we're going to run into some issues. After you leave time 0, where there's one prediction, there are 2 predictions at every point in time as you move forward. And so from there on, from time 0 on, it has no functional value. So the relationship is not a function. Doesn't pass the vertical line test, or more importantly, there are multiple predictions at the same time. The x values are not unique, they repeat. If you go on down to number 4, you've heard me suggest this before, that vertical lines are not functions. So this is a vertical line that goes straight up and down, and this is technically the relationship known as x equals 5. X is, there are an infinite number of predictions 5 units of time from now. So if you look at this, 5 units of time from now, x could be 0. In 5 units of time from now, when x is 5, the measured amounts could be 0, they could be 1, they could be 2, they could be 3, they could be 4, they could be 5, they could be negative 1, negative 2, negative 3. So there's an infinite number of predictions. We see 5, 0, 5, 1. At 5 units time from now can measure 2. 5 units time from now can measure negative 1. 5 units time from now can measure negative 2. This is completely useless. There's an infinite number of predictions at the same point in time. And the only way to really identify that relationship is just saying that x equals 5. Anything can happen 5 units time from now. That is not a function. Based on that data and information, I would suggest you pause the video and see if you can determine if each of the relationships is a function. I recommend that you take a ruler or a straight edge and you run it across the relationship to get a visual interpretation as to whether or not your relationship is a function. So quickly, you'll just go across number 5. You'll go across number 6 as you work on down. You can challenge yourself and see what you think about number 7, 8, and 9. Give it a shot. Okay, ladies and gentlemen, assuming you gave it a shot, I hope that at number 5, this looks familiar to you because we've seen this over the past few days. As you scan through the behavior, working your way from the past into the future, left to right, you should notice that at every point in time, you only hit the graph once with your vertical line. There aren't 2 x's on the same vertical line, meaning 2 predictions at a time. This is just a piecewise linear function. It is most certainly a function that makes predictions one at a time. Number 6 is even more boring because as you scan through number 6, it just stays the same. It never goes up, it never goes down. In all these points in time, y is always 5. And for horizontal lines that go straight through the y-axis, those are y equals equations. That just suggests that y will always equal 5. It'll never increase. It'll never decrease. Or you could have written that as y equals 5 plus 0 over and over again x number of times to see that linear relationship. 7, similar to number 5, is just a piecewise linear function that begins by decreasing, then goes up slightly, then stays the same or constant for a while, then continues to go up. But in all points of time, we notice that there's only one point of intersection with our vertical line and the relationship. So yes, that is a function. That is a piecewise linear function. Number 8 looks awkward, but don't be scared. You got to follow the rules here. If you were to take a vertical line and drag it across the entire relationship from the past into the future, you would notice that at every point in time, there's only one point of intersection. The portions that are a little difficult to interpret are where the graph jumps for some reason or another. So where somebody's health all of a sudden gets worse, or all of a sudden improves, or somebody's wealth, they win the lotto and immediately they jump up and they're super wealthy. So at those points where the relationship jumps, you just have to check and make sure there's only one point of intersection or one prediction. The prediction is the closed circle. So long as there's not two closed circles or an overlap at that point, then it will be a function. And this relationship actually is a function. In number 9, however, you notice that 5 units of time ago, there were two closed circles. And because there were two closed circles, it was predicted that 5 units of time ago, the relationship would measure either 0 or the relationship would measure -4. And the x values are repeating there. There's two predictions at the same time. That's not a function. And it happens again past 1 unit of time from now. There's overlap in the two segments, and therefore there's two predictions at a time, and that is not a function. When you go in the back of the worksheet, it's actually even simpler if it shows up as a table of values, because in a table of values, to identify if the points that we could plot and make a pattern out of, make some relationship, whether it's a line or something else, are a function, you simply have to make sure the x values are unique and that they do not repeat. And to do that, you just take your eye and you scan down the x values and you make sure there's no repeat. 2, 4, 6, 8, 10, 12. There's no repeat. That is a function. Yes. Number 2. -8, 8 units time ago, 4 units time ago, 2 units time ago, right now, 2, 4. Those are unique. That's perfect. Awesome. That is a function. And you would continue to do that for each of them. I'll finish up the top row with you. Number 3, 14 units of time from now, 8 units time from now, 2 units time from now, 4 units time ago, 2 up. There's repeat. I'm seeing 2 predictions at time 2. I'm also seeing 2 predictions happening 8 units of time from now. 8 units time from now, 8 units time from now. And that suggests that this is not a function. So once again, we're seeing 8 comma -4 and 8 comma +4. So 8 units time from now, the relationship could either be positive or -4. And we're seeing similarly, there's 2 predictions at time 2. This is not a function. For number 5, the x values are unique. 1, 2, 3, 4, 5, 6. But Tooch, wait a minute, time out, man. The y values repeat. The y is 5. Okay. So what that says is, we already saw this. So that's on the last page. 1 unit time from now, it measures 5. 2 units time from that measures 5. 3 units time from that measures 5. 4 units time from that measures 5. It is always 5. It's a horizontal line or a y equals equation. Y equals equations will go straight through the y-axis, and that is just a constant function. Yes, that's a function. We had a yes, and we had a yes. Give 5, 6, 7, and 8 a shot on your own. Please pause the video. In number 5, ladies and gentlemen, as you scan down the x column, you notice that all the x units of time are unique. Therefore, there's no repeated predictions at any point in time. This makes this a useful equation or a function, and yes, it is. In number 6, there are multiple predictions at time 3, as well as 1 moment of time ago, and right now at time 0. That is not a function. The x values must be unique. They may not repeat. In number 7, if you investigate simply the x variable and what times are investigating it, they're all unique. That is a function. And in number 8, you notice that at time 5, there's a bunch of predictions. So what that is going to suggest is that 5 units of time from now, the relationship can measure either 1, or it can measure 2, or it can measure 3, or it can measure 4, or it can measure 5. And hopefully, like, oh, I get it, Tooch. That is going to be a vertical relationship. And a vertical relationship is not a function. There's an infinite number of predictions. This is an x equals equation. This is x equals 5. There's an infinite number of predictions 5 units of time from now. And we sometimes say that x equals equations go straight through the x-axis to help you remember. Not a function. Cool. It's even easier down below with number 9, because number 9, with the next section and number 9, that's similarly related to table of values. And if it freaks you out to look at the data this way, you can make your own table of values. When you're looking at points and measured amounts throughout time, it's always x comma y. So if you wanted, you could say, Tooch, don't I have at time 2 it measures 3, and it doesn't suggest at time 4 it measures 4, and at time 6 it measures 5, and at time 8 it measures 6, and at time 10 it measures 7. You can make your own table, but it's not necessary. As long as you understand that the x variable is the first position in the ordered pair, you just need to check out or investigate that first position. and you need to determine, is the x variable unique? And so long as it is a function, and they are for this one. The domain refers to how much of the x-axis did we use, and we went from time 2 up to time 10, so we'd say from 2 to 10 and all possible x values in between. And the range refers to how much of the y-axis did we use, what were the measured amounts going from and to. And they went as low as 3 and as high as 7. So our measured amounts went from 3 up to 7, and that was our y variable. We wouldn't consider domain and range if it wasn't a function. So I can take a look at number 10 with you. And in number 10, ladies and gentlemen, to determine if it's a function, your x values must be unique. They may not repeat. We can't have multiple predictions at the same point in time. So we simply need to investigate the x variable and make sure there is no repeat in time. And in this instance, there's repeat at time 2, where we believe that the measured amount could be either -2 or +2. Therefore, it is not a function, and we're not going to worry about the domain and range. Give number 11 and 12 a shot. Pause the video. In number 11, ladies and gentlemen, if you investigate the x variable, the units of time, you notice that we're measuring this relationship from time 1 up to time 5, and there is no repeat in the x variable. There's not multiple predictions at the same time. Therefore, it is a function. It's a useful graph that will make predictions into the future one at a time. The domain starts at 1 and ends at 5. D comes before R, X comes before Y. Domain refers to how much of the x-axis we use. And in this relationship, we're going from time 1 up to time 5. The range is super boring. That's what our measured amounts consider over this unit of time, and they're just always 5. This is that horizontal constant function where y is always 5. It's a y equals equation that will go straight through the y-axis. The opposite of that is number 12, which is not a function. It's not because there are multiple predictions at time 5. There's many predictions at time 5. The x values must be unique. They may not repeat. That is not a function. And technically, that again is going to be that vertical relationship where x equals 5. And x equals equations are going to go straight through the x-axis. That's going to help you remember that those relationships are vertical. Down below, we're showing you the final presentation of how this is often shown. And we often show functions in what we call a mapping. And in a mapping, we'll often call the x variable the input, the amount that you're putting in or the time that you're putting in and investigating. And we'll call the y variable the output, what you get out at that time, what your prediction is. And we'll often say as a result of that, there should be only one output for every input. In order for the x values to be unique, there can be only one y value or output per input. Another interpretation, as we suggested, the y's are the outputs. They're also sometimes called the mappings. And we will say that each x variable may map onto only one y amount or output, meaning that for every time you put an x in, you should only get one prediction out. It can be a little confusing to look at, but it doesn't have to be. You could make it a presentation that's more familiar to you if you want. So it's possible to take this mapping of these x values, which we call the inputs, what time we're putting into our relationship or our domain, and our y values, our output, and you can make them into coordinate pairs. You could say, Tooch, don't I just have that at time 2, it's going to measure 3, if I follow the arrow appropriately? Don't I have that at time 4, it's going to measure 4? And at time 6, it's going to measure 5. At time 8, it's going to measure 5 as well. At time 10, it's also going to measure 5. And at time 12, it's going to measure 8. And you can further make that into a table of values if you want to. But the most important thing about putting it into a coordinate pair set is that you can see quite clearly that the x values are unique and they do not repeat. Therefore, the relationship is a function. If you do the same thing with number 14, it's really boring as all heck. 6 units of time ago, it measures -3. 3 units of time ago, it measures -3. Right now, it's measuring -3, and it continues to measure -3. And if you set them up as points, you'd have -6, -3. You'd have -3, -3, and so forth. And the x variables would not repeat. This is a function. It's very useful. It's boring as all heck. This is technically the relationship where y just equals -3. It never changes, and that would graph as a horizontal line. Now, the opposite of that is what we're seeing in number 15. And in number 15, we notice that at time 4, there's a ton of predictions. 4 units of time from now, the relationship could possibly measure 8, but 4 units of time from now, it could also measure 9 and 10 and 11 and 12 and 13 and so forth. As a graph, 4 units of time from now, we're going to see that there is a vertical line here. It's going to go straight up and down. There's going to be an infinite number of predictions, or in this case, there's actually 1, 2, 3, 4, 5, 6 predictions at the same time. And therefore, that is not going to be useful to us, so there it is not a function. Ladies and gentlemen, this is the lesson on functional relationships, and it's really kind of simple. In order for a relationship to be a function, it must be working or useful. And mathematically, what that means is it can only make one prediction at a time. And in order for it to make one prediction at a time, the x values must be unique. They may not repeat. That's it. Good luck, and I'll see you in class. Take care.